20th century, some new discoveries from different perspectives, from science, from psychology, from biology, starting to show us, oh, it could be a risk to work with reductionism because the whole is greater than the sum of its parts. Okay, and a new field starts to show up. That is complexity. Okay, so we have the theory of complexity, and we understand the complexity and the behaviors of complexity. And to start simple, I brought a definition here for you. That's from Melanie Mitchell. That's from the Santa Fe Institute. And she said, the word complex comes from Latin root plecter, to wave and wind. In complex systems, many simple parts are irreducible and finite, and the field of complexity is itself an antinomy of many different fields. Okay, so now we start to think the whole could be a company, could be a soccer team, could be the global economy as a system. And this system is composed by different parts that is those parts are irreducibly end-to-end. And those parts interact with each other in a non-linear way. So that's why we say that the whole is greater than the sum of the parts. And it's like a complex interaction between those players. And it brings us a difficult to understand the reality, and it brings us like one maybe difficult, that is uncertainty. If we are dealing with complexity, maybe probably we will have to deal with uncertainty. It's very complex, it's very different than the perspective of determinism from Laplace, because the parts could then suddenly interact in such a way that the whole system will start to behave in a different way. And just to show you, I will start with the butterfly effect. Uh, You probably heard about that, okay? But what is butterfly effect? It's sensitivity to initial conditions. It's the idea that small things can have nonlinear impacts on a complex system. And here I bring it to you in this image, an experiment from Edward Lorenz. And Edward Lorenz worked at MIT as in the climate and the weather prediction, and he had a computer, a machinery to do all those calculations. And in one day, he figured out that the prediction starts correct for 1 day, 2 day, 3 day, and in the fourth day, the prediction starts to go crazy. And he thought, why it's happening? Maybe it's a problem in the computer. But it was not a problem in the computer. In fact, he found the problem. He realized that when he entered the numbers to start the simulation, he put a wrong number, but a very, very, very small number, decimal number. That's why in the beginning the system starts very close to the prediction and then starts to go away, because he realized that this kind of the system has a chaotic behavior. That's the theory of chaos. So a single and very simple and small change could impact the whole system and could put the system to behave in a completely different way than it was predicted. And the butterfly effect is called on this way because actually it's true. He wrote this report, and the subject of this report, as you can see here, is predictability. Né? Does the flap of a butterfly's wing in Brazil set off a tornado in Texas? So just a simple change in the system, that's the flap of a butterfly's wing, just a simple change in the system could cause a tornado in Texas. So that's why it's called the butterfly effect. Okay? And here, just to show you, I brought a poem from George Herbert. And he wrote, "For want of a nail, the show was lost. For want of a show, the horse was lost. For want of a horse, the rider was lost. For want of a rider, the message was lost. For want of a message, the battle was lost. For want of a battle, the kingdom was lost. And all for the want of horseshoe nail." So he said, the nail caused the kingdom to be lost. Okay? That's what we call chaos theory. So one single change in the system can cause unpredictable behavior. And that's what we are living today, right? One virus in China then spread out around the world. And here I bring a perspective just to start to think and apply those concepts in our society today. I bring here one concept that's called the Black Swan from Nicolas Taleb. Okay, and he called the Black Swan as an unpredictable event that will happen in the world. And here's the definition. First, it is an outlier, as it lies outside the realm of regular expectations, because nothing in the past can convincingly point to its possibility. Second, it carries an extreme impact. Third, in spite of its outlier status, human nature makes us concoct explanation for its occurrence after the fact, make it explainable and predictable. So he's saying that we are facing many black sauce events in our reality, okay? And it's like an outlier, so it's not part of our regular expectations, but it carries an extreme impact, and it disrupts the reality, disrupt the system. And then after that, we started to make it plausible explanation why it would be predictable. And we are living now in a situation like the pandemics that is important to us to think about it. Okay? So, for example, I will ask you a question. When the pandemic will stop? will end? When you have the first vaccines, what will be the impact in global economy? You are living right now a black sock, okay? And we cannot break the reality in small parts and study each alone. We need to have a complex view of the world. And that's what we will discuss more with tools and techniques to deal with this in our next lecture. Alright, so we have now a reading time with many texts to help you to understand and go deeper on those topics. Alright, thank you and feel free to ask questions in our environment, in our online environment. See you later.